All right, so we're going to continue our conversation on optimizing a multivariate function. All right, so here's our example. F of xy equals 120x minus 4x squared plus 2xy minus 3y squared plus 96y minus 102. I would ask you to say that 5 times fast, but you didn't last time, so I won't ask you this time. Well, let's go ahead and optimize this function. So to do so, we have f of x, and we want to set that equal to 0, and f sub y equals 0 as our first order condition. All right, so therefore f sub x is equal to 120 minus 8x plus 2y is equal to 0. F sub y is equal to 2x minus 6y plus 96 is equal to 0. So we can solve this out by hand, but as we showed last time, that's not very fun to do. So let's go ahead and look at Excel to see how Excel can help us out. So here I cheated and wrote ahead. So here we have f sub x, which is written as 120 minus 8x plus 2y, which is exactly what we had for f sub x. Now for f sub y, we have 2x minus 6y plus 96. And so now we just need to go to solver and realize that our objective is to set f of x to the value of 0 by changing x and y with the constraint that f sub y is also equal to 0. So I click solve, and I find the answer for x is 20.73, and for y is 22.91. So coming back here, we get x star is equal to 20.73 and y star is equal to 22.91. Now we want to know if that's a max or a min. So our second stage, our second condition, is to set the second partial derivative, which for f of x with respect to x is negative 8, and fyy is equal to negative 6. Both of these are less than 0, so we've established a max. So if this is a max function, meaning it's concave, it looks something like this, the frowny face, then we can think of f of xy as a profit function of producing good x and producing good y. So think of this as in your factory you have a machine, and in order to make the most profits you want to use that machine to produce 20.73 units of x and 22.91 units of y. But here might be the problem. Suppose your machine can't produce that amount. Suppose you have a constraint such that x plus 3y has to be less than or equal to 69. Meaning if you were to run your machine all day, you could produce at most 69 units of x. Because if y is 0, x could be at most 69. But let's suppose we only produce y. So if x is 0, the most y could be would be 23. Well, if the most we can produce is 23y with producing 0x, we can't actually get this allocation of x and y. That violates this constraint. And so what we want to do is be able to incorporate this constraint into our original function. The way we do that is a method called Lagrange. In the next session, we'll talk about how we actually set up a Lagrange. But what we want to do here is just simply incorporate this into Excel to see if we can maximize this equation with a constraint. So let's go back to Excel to where we were. And so now we're going to set up the function f of x, y, which is equal to 120 times x minus 4 times x squared plus 2 times x times y minus 3 times y squared plus 96 times y minus 102. So now here's our function. Well, we also have the constraint. So the constraint has two sides. We have our left-hand side and our right-hand side. The right-hand side of our constraint is simply 69. The left-hand side of our constraint, as we showed, was equal to x plus 3 times y. And so now as we go back into Solver, we want to change this up a little. So our objective now is not B4, but our objective is f of x, y. And we want to maximize that by changing x and y. But now our constraint is different. We want to add the constraint such that our left-hand side, x plus 3y, is less than or equal to the right-hand side. And now we click Solve, and now we have the x and y that maximize profits subject to our constraint. So before, to maximize profits, we'd produce 20.73 of x and 22.91 of y. But with our constraints, now our x star is equal to 18, our y star is equal to 17. Meaning this, given this constraint that our machine can only produce a certain quantity of x and y, the most we can make, the way we can make the best profits is to produce 18 of x and 17 of y.